And so okay, it's recording now. So if one of you wanted to go over the main slides right now, you can as well. Or was there like another slide for the like sort of informational stuff?
Yeah, I'll do the informational slide. Can you see my screen?
Yes.
Okay, cool. So Women Who Code is a global nonprofit dedicated to inspiring women to excel in their careers. We work to support our fellow women to become leaders and role models in the tech industry. And we are the DC chapter. So you definitely join us on our Slack chat. There's links to that here, and I can post them on the chat as well. We typically meet Wednesday of each month. I guess over the summer we've not really stayed on top of this cadence, but I'm guessing in the fall we will resume. Let's see. So yeah, I think that's it. With that, we can get started, Anastassia.
Okay, well, let me then switch to sharing my screen. Great, so yeah, so we should be able to get started now. Do you guys see the collab notebook? What's happening?
Yep.
Okay, sorry, my computer freaked out for like half a second. Yeah, so I guess really briefly about myself, I am a research data scientist at a company called Fiscal Node that analyzes legislative regulatory data and kind of aggregates it for analysis and collaboration for various companies. So most of my work is in text analysis, but working on a small team, I also do a lot of my own data engineering, which is kind of where all the testing comes into play because we want to build reliable services. So this is kind of like, I thought these are some cool topics, which again, the materials on them I think are a little tricky. So I thought it'd be kind of fun to do a little bit of a lab about like how to do more fancy testing in Python. So that's what I'm talking about this time. If you look me up, I also talk a lot about natural language processing, but thought it'd be a fun change of pace. So for testing, the stuff we're going to talk about today mostly focuses on unit tests, which are sort of tests you run on individual pieces of code to make sure it works no matter what. There's another brand of test called integration testing, where you test that all of your systems work together. And a lot of, I think, web development or like more like full-scale test development engineers have a lot of additional tools they use to build that, but this kind of focuses more on you like kind of wrote some of your own code, or like you're working on specific code base and you want to make sure that you didn't break it and then it works how you expected it and such. So that's kind of the context for this lab. So we're kind of going to focus on first more advanced functionality of pytest, which is a popular library for testing in Python. And then we're going to talk about patching and mocking, which is a way to sort of fake some of the structures that you aren't testing. So that's the overview. Hopefully that all sounds good. Again, feel free to use the little hand raise thing if you get confused. So as I mentioned briefly, if you want to run the cells in the notebook, you can press the little run cell button. So unlike some of the other stuff, usually each cell is basically a little bit of Python interpreter, but in this case, it's not quite that. This little write file thing essentially writes it out to a file, because the pytest library, it's something you run from your command line and you point it to a file, and then it runs all the functions that start with like test underscore. So essentially it runs them and sees if they've passed or failed. So in this like fake example, we sort of have a function which adds 1 to something. So we might have a test where like, is the function of 4 equal to 5? And this will pass. It won't raise any assertion errors because 4 plus 1 is 5. And this one would fail because 33 plus 1 is in fact not 5. And then this final one, we actually put a special header on it, which means that we want to make sure that it fails in fact. So that's kind of all the code. So it's now in a file, and you can actually see the file system here on the left. So it's over there. I'm not going to click on it so it doesn't switch my screen. And then using, again, this little exclamation point, that means you're going to run it from your command line. So the usual workflow for this might be you're developing. So you have your main code base, then you have a file of tests. And then before you maybe like commit or merge your code, you would run this on your command line. So you have python -m pytest, and you have test.py. So on this thing, it is pre-installed, but locally you might need to install it first with pip install pytest. So when we run this, and actually I'm going to clear my thing so you don't see the answers, we see that one of our tests in fact failed, which is bad because, and it explains why it failed. So it actually does a bunch of the evaluation for you. So it says 34 is not equal to 5. So just give me a second to clear the screens. I should have 1 second. I think if I restarted now, it should have them. So if you had it also showing with all the answers, I think the way to clean that would be, so you don't see them if you don't want ahead of time, would be to go to, I'm trying to remember where you go to. 1 second. If somebody remembers how to clear all the outputs, feel free to comment. I did this recently and they can't find it. Sorry, I'm just trying to, as I said, clear all the outputs so we can talk through them from scratch. I'm sorry, this is, oh, there, under edit, there's clear all outputs. Apologies about that. So yeah, if you go under edit and clear all outputs, it will clear them. So you can go from scratch, but anyway. So going back to this, we ran this test and, well, and what we see is that, well, I have to go from the beginning. Anyway, so what we see here is that tells us which tests have failed. So this is kind of like, this is the most basic pytest. So essentially you write a function and usually you write it to do some stuff. And then you have this assert statement. And then when you run the pytests, it sort of tells you what passed and what failed. So that's kind of the most basic test you can write. It doesn't really do anything too tricky besides saying that this test should actually fail. The next thing you can do is parametrize test. So sometimes you want to basically run the same function, but you want to test it in a bunch of different cases. So for example, here we're testing a sum. So we can again do this wrapper called mark.parametrize, and you tell it what variables you're going to pass in. And then you, on the next lines, you have series of variables, and essentially then when you pass them into, it does kind of like dependency resolution magic. And then once you do that, you can essentially test a bunch of variables at once. So once we run this, we will see that we actually ran 2 tests. Even though we have 1 test function, we actually ran 2 whole tests. So I see one of you asked, what does pytest.mark.fail do? So what that does, it counts a test failing as passing. Like your goal essentially is to have all of your tests pass. And here we have 1 test that X failed, which is different from actually failing. So essentially it's telling your code that this is a test I do not want to pass. And it still marks it as a win in that sense. So hopefully that's helpful. If not, feel free to ask a follow-up question, but this is sort of all setting the scene for just like how different tests look. So that's kind of the basics. And now we're gonna sort of jump into a few more advanced concepts, but any questions about the basics of how this type of testing works? Obviously, you do reality be testing more complex functions, but any questions so far? Okay, great.
Did
So,
you, sorry,
yeah.
Did you see the question from Shadana?
Yes, I think I said that essentially this tells your code that it's okay to fail this test. Like it essentially counts failing this test as a good thing. So usually you don't want your test to fail. So this is why here it told us that test bad answer failed, and that corresponds to this test. But it didn't say anything bad about this test because we wanted this test to fail. So essentially it tells your code to do the opposite. Does that make sense?
It does. What happens if the assertion is true in that X?
Well, let's try it out. So if we now make the test actually pass, I'm sorry, it's like, so what we see in this case is that it actually, well, it actually says it X pass. So basically with this specific framework, it will still mark it as pass. So I think it's just sort of, it's like, it gives you information about what happened, but it doesn't like necessarily like cause it to fail or pass. So it's a slightly more obscure concept. I actually don't use it that much. It sort of is like kind of half ignoring the test. You're like, because usually the idea is sometimes you might run these like on GitHub as part of your deploy, and like if one of them fails, you're like, you don't want your code to deploy. But with the X mark tests, like it wouldn't stop that process. It's just kind of passively giving you that information.
Okay.
So it's kind of more obscure, like you probably don't need it as much, but it's kind of like a handy reference to have in mind. But I don't think I actually ever use these myself, but
Got it. So Sharda, to answer your question and Sahidi's question, I wouldn't use that to add in negative test scenarios. I would write those failure scenarios and assert the failures in a regular test, right? Because if your failure scenarios start failing or passing rather, and you don't want your build to proceed, you want to catch that.
Yeah, so this is kind of a more obscure, like kind of passive case. So it's, I would actually, yeah, I'll do more research later and maybe post it somewhere, but it's kind of like a more weird case, to be honest. So yeah, but that's this set of things. So now we're going to talk about fixtures. So the idea behind fixtures is that you might have some kind of code that you need to like set up before you run the code you actually want to test. So far everything we've done was very self-contained, but in reality, there might be like database connections you need to make to collect some data, or maybe you want to call like an external API first to collect some data, or you want to essentially, I don't know, create a local database that you're going to use for testing that's not your production database. So there might be a lot of like steps that aren't really part of your test, but need to be done in order to have your test run. And the way sort of PyTest approaches that is with this concept of fixtures, which essentially are a bunch of functions that will create some kind of resource. So that could be a link to a database, that could just be a dictionary, it could be anything really, but sort of those passing or failing don't count as part of the test, and they also can be reused. Yes, it's essentially kind of like a setup and tear down as a concept. So that's right, Miranda. That's kind of the element of it. So, and essentially like if like, yeah, the documentation link here actually like provides really good reasoning behind why they do this way. Essentially, they break down each test into kind of 4 elements around sort of setup, running some code, verifying your code, and then tearing your code down. So they kind of provide a nice framework for that. So if you want to get deeper into it, I recommend reading that later. But let's say right now we're going to sort of go for a simple test where we're going to sort of see the efficacy of this. So let's say we're sort of testing some kind of linguistic library we wrote, because I love language, I work in natural language processing. So let's say we want to download the list of the 1,000 most common words in the English language, and then we want to test a bunch of properties of that list. And so the idea of the fixture here is like, we don't want our actual test to fail if, say, the request didn't work because the internet was down, or maybe we don't even want to keep downloading that list multiple times because that's slow and we want to run a bunch of tests on it. So these are all the reasons you might want to use the fixture. So for example, here we have two pieces. So our actual test, and we know it's a test because there's the little method, sorry, because it says test underscore in the beginning is here, and it's not going to take in a variable. And then it's going to use that variable to assert something. So here we're going to verify that there are indeed 1,000 words in this list. So the way it sort of figures out where this parameter comes from, so it's like, how does it find common English words? It's sort of this kind of crazy thing with dependency injection where essentially anything marked as a fixture becomes kind of an element that can be found. So we use this pytest.fixture thing. And what that does is that it basically tells the computer when you have common English words, find the thing marked as that and transform that to be that variable. So it's like a weird dependency lookup thing. It's not super common in Python, but if you worked with Java before, here it's more common there. But essentially it gives a way to link this element we've constructed to this test. So here we're going to write that down into a file again. And then when we run our test, we'll see that our test passed because indeed this was a list of 1,000 words, as I mentioned. So that's kind of an element of fixtures, and obviously very simple example. So as I mentioned, one of the nice elements of fixtures is that it sort of lets you separate failures in your test from failures in your resources. So if, say, for example, like are getting the list failed because I put a raise value error into it to simulate the test failing. So now when we run this code, like we'll see a different type of error. So we'll see an error at setup. So instead of kind of telling us that our test failed, so before we had a failure where our test failed, now we're going to have a different error. So it sort of separates your code failing from your resources failing. And that's very helpful because your test should all point at a very specific thing. Because if your test looks at like 20 things at once, you won't know where in your code to look to fix it. So it's helpful for sort of separating your elements mentally as well as reusing certain pieces of code between different tests. So again, as I'm sort of alluded to, we can also reuse these lists. So there is a sort of thing you can pass in. So instead of just being at pytest.fixture, you can add parentheses, and inside those parentheses put scope equals something. So there's section method, session method, and a few others. And what this basically tells your code is to only download this list once. It means that once per session, which is sort of one time of running pytest, download this list once, and then this function and this function will both be able to use the same copy, and you won't have to download it every single time. So far, does that make sense? Any questions around that? Okay, so just a couple more things around fixtures that I want to touch on, and then we might switch to talking about mocks. So another neat thing is that these fixtures can be nested. So for example, we have our first fixtures, common English words, and now we want to introduce a sorted version of that list. So once we mark it as a fixture, the code can actually also look for other fixtures. So you tell it, find common English words, and it's able to find that and produce them as an output of this current fixture. So it's kind of a neat element to have. And like one way to think about it is, for example, you want to like, you have a lot of code that deals with databases. So you want to maybe use the little local database to test out your code. So you're going to like create a table in that code. And for example, you maybe only want to create each table per test. So maybe because you want to start from scratch every time, then you might set your scope to be a function, but maybe creating the whole database, like instantiating SQLite, can only happen once per session. So you can kind of vary it depending on your needs. So for example, for this test, we're going to create a database, which in this case will be just a Python dictionary. And by default, it does actually use the session scope. And then we're going to kind of create a table within it. So this time we're going to mark it as having the scope of a function. and it's going to look up the database. And so to create a table, it's going to essentially just have a table called test only, and that's also going to be a dictionary. And then by using yield, we're essentially able to return it. And then sort of the nice element that's sort of the teardown, as Miranda noticed, is that anything called after the yield will run after your function is finished. And in this case, it's essentially equivalent to us deleting that table. So in this case, for example, our function tested that we actually inserted something, but after all of this code ran, that main dictionary would get rid of that table. So that's kind of another element of a basic part of how teardown works. So hopefully all of these pieces give you a basic sense of like how you can incorporate external resources into your testing or reuse certain elements of tests, whether you parametrize the test so you can test a bunch of inputs at once, or you could share the same database connection, or share like maybe loading a library that takes a lot of resources to load so you don't keep reloading of every test. Because again, the nice thing about unit tests is that they should run very quickly so you can kind of iterate quickly with them. So questions, curiosities? I'm going to take a second to sip my tea, but if you have anything, comments, ideas so far, what stuff has worked for you with PyTest or not, holla at us. Okay, well, let's talk about mocks and patches then. So the case for mocks and patches comes down to the idea that your unit tests should be self-contained. They shouldn't rely, for example, like we have here on the day of the week. You want to make sure that if a test passes on a Thursday, that same test is going to pass on a Sunday, or that your tests work regardless of like what data is actually in your database, because that might be more of a role for integration test, which makes sure that all the users are still there. But the idea of unit tests is to sort of have things that are reusable. And part of making things reusable means sometimes faking parts of your code that you're not really interested in. So my first example here is actually like probably not the best practice, because in fact, for testing with time, there's a special library called FreezeGun. But this example sort of is like a gentle introduction into mocks. So let's say we have a function called isWeekend, which pulls up the current date. And if it's a weekday, it returns, sorry, if the weekday function, which tells you like numerically which day of the week it is. And so if it's like a Saturday or a Sunday, it will return true. And otherwise it will return false. So if we run this function right now, it's going to say, well, I didn't actually run the first piece of code, so that's why it would have failed. It's going to say false because today is a Wednesday. But obviously, I want to also make sure that this code works on a Saturday without having to wait around for a Saturday. So in this case, what we can do is use a mock. So I'll go a little deeper into what mock does, but to start, essentially what we can do is create a mock for the date object, and then add a function to it, a new function to it called date.today. And within this mock, we tell it to have a return value of 2021, 7, 28. So that's today. And we're going to run this test. And we're going to have a second test where we set the return value to be 2021-7-31. So 3 days from now, or Saturday. And in this case, we're now able to test that the rest of the functionality is correct for both like a weekday and a weekend. So if you have external dependencies in your code, mocks are one way to sort of help you deal with that. So that's kind of the basic idea behind a mock, is you can essentially take any piece of Python code or like any Python function or like class and replace it with a mock, and you just tell that mock what to do and it does that. That's sort of the high level idea of it. But with that in mind, I've come up with an example that can sort of help breaking down in terms of more practical terms. So let's say like one place a mock might be helpful is like if you usually need to call an external API. Say you need to call Google Translate, but you don't want to do that every time you run your tests because it's expensive and maybe you don't want to put your API key on your testing server, there might be different reasons for doing that. So we'll kind of go through how to mock that piece of your code, because let's say for this specific unit test, like we don't really care about the true translation. We just want to make sure our code handles that translation correctly. So we're going to have a class called translate and count, and it's going to have a function called translate and count. And what it's essentially going to do is it's going to take in some text, it's going to run it through a translation API, and then it's going to count the number of words in the translation. And let's say we want to make sure that this length and this split function work correctly, because they're secretly much fancier functions and we don't really care about what's going on in this API handler. We just want to get back some new text that we're going to work with. So this is one case where mocking might be helpful. So in our test file, so now we're going back to kind of having tests, except I'm not going to use pytest. I'm just going to run them for the sake of kind of simplicity. What we're going to do is that we note here that our translate and count class takes in an API handler, but instead of passing it in the real API handler, we're going to make up a fake one. So the API handler itself is going to be a mock object, which is sort of a kind of an object that can be extended in every which way. And now we're going to write we're going to make up a function in it. So we're going to define the API handler, the get translation function. So this is not how you usually are able to define things in Python, but mocks kind of give you a workaround. And here again, we're going to call it a mock. So this is imported from a default library of unittest.mocks. And we're going to essentially hard code a return value, which means that no matter what I call this get translation function with now, it's always going to return aim Python, so like Python. And then we're going to pass in our fake API handler into this function. And once we run it, it's going to return the result of 2. And we know, well, because it doesn't yet, because it didn't run this first cell, you have to run them in order. So once we do this, essentially because nothing got raised, it means our code passed because we sort of knew that aim Python had exactly 2 words. So by doing this, we were sort of able to get rid of that external API call and instead do this fake one. So that's sort of how mocking works in a very basic form. So questions, confusion, etc. with that? So I will point out that that is actually pretty similar to actually defining a fake API handler class. Maybe that extends API handler and then writing a little function in it, but mocking sort of like gets rid of the need to write out this whole big class and lets you kind of do it in a much simpler inline format without defining this extra structure. So I've been saying that mocks kind of let you do whatever you want, and indeed, if we kind of just try to print it out to see what it is, it's an object of type mock. And every time we create one, just has a unique ID you can reference later. And if it's a function, so if it extends something as like a mock of a mock, it will also get a name that can be used to find it. So for example, mocks can be given properties. So for example, if you have a mock and you assign mock.orange to 20, you can later see that that is still 20. And also you can, for example, just automatically define a function. So by calling any function on a mock, it will like automatically define that function. So where that's helpful is, for example, let's say the fake API handler had a bunch of other methods that we don't care about. They could easily get called and they would just return a mock back. And that means that we don't need to define all the other functions we don't care about in our fake class, because essentially their results would just kind of, their like functions would just automatically be created. So it's kind of neat, and hopefully we'll see that in the example at the end. So another nice thing is that it not only lets you like create things, it actually also lets you see which properties of the mock got called. So there is a thing called call count. So we have our mock.getApples, which got created when we called it. And we see that, we'll actually need this. So we see that before it was 1, and then when we call it again, now it is 2. And again, there's variations. For example, you can assert it only got once, which would be false because we called it 2. And we can even see what it was called with. So an alternative way you might want to use mocks is, for example, you want to make sure that somewhere in your code internally, it called the right functions the right number of times. For example, you want to make sure that you only called the translation API once and there wasn't a bug where you accidentally spent 10 times as much money calling your translation API due to some weird while loop or something. So that's kind of like another bonus feature of using mocks. And as I already mentioned, you might want to combine these things. So while I did say that you want to use tests separately, usually sometimes it makes sense to combine a couple of small things. So going back to our earlier example, for example, we can have a mock that gets a hard-coded return value, and then we test it, and we can also then test that the code was indeed called only once, as I just sort of suggested that it might be. And sort of the last little nice property of mocks specifically is that you can also have them have a side effect instead. So for example, let's say we want to make sure that our code handles timeouts properly, like if the API didn't respond. So instead of a return value, you can pass in a side effect. And then when this function is called, you will in fact get a timeout. So this is kind of like an alternative way you can also use these tests. Like if you're testing your error handling, you can pass in a side effect, and then this function will trigger this like error when you call it. So that's like one additional nice property of how you could use mocks. And there is like this essentially shorthand syntax where you can pass in all the functions and their definitions in line, but I personally prefer writing it out. It's a little more readable. So that's kind of it for mocking specifically. So we're gonna have like maybe a minute exercise at the end if there's time and interest, but again, wanted to give you guys a chance to ask any questions about this. Yeah, so mocks are kind of like a tool you can use within your PyTest. So PyTest is like not part of the Python standard library, but mocks are. So I have everything I've been writing so far, like this test, TAC Laura, I'm responding to your question. So this could be run then like externally by a PyTest. I just kind of put it in line for simplicity. So mocks are one of the tools you would use within your PyTests. PyTest is a framework for actually running the test itself. Does that make sense?
Thanks. Yes, I just wasn't sure if you needed to use unit test when you're running tests that involve mocks, or if PyTest, if that can all be integrated together.
They can all be used together. And I know they are built in unit tests in Python as well. This is just sort of my personal preference. Yeah, but they work together. So cool. Okay. So mocks obviously have a lot of purposes. For example, causing a side effect or testing to see if a certain variable was called. But sometimes we don't want to mock out a full function or a full class, or sometimes we want to mock out some internal function and we'd have to build like a mock of a mock of a mock to get to it. And this is sort of a case where patching comes in, because patching lets you define a path to a specific function and only replace that function. So let's go back to our translate and count example. And let's say that right now we don't have an external API handler, and instead we just had a method which calls our external API. So with all of this, we wouldn't really make sense for us to, so this is going to be the test piece. So let's look at just the class piece. So when we have all of this, we don't really want to mock the translate and count class, because we're still testing our main function. We only want to essentially, in fact, replace this internal request.get call, which we didn't even define, that comes from the requests library. So this is sort of where mocks can come into play and are helpful. So we have now a new test, and in this test, we're going to define the translate and count class. And then what we're going to have is a statement we're going to do with. And now we have this patch code. And so the patch code can take in 2 inputs. So first you kind of tell it the path to the thing you want to replace. And in this case, we used main because it's in this like main body of code. Usually it'd be a path to like the module where it's defined, and you can make this path as complex as you need to. So this essentially tells you which method we are getting rid of. And then you can pair it with the response to that method. So the second thing in the parentheses would be the new response we're getting when we're calling this method. So in this case, instead of this method, we're going to create a mock with a return value of 4 words this time. And then when we call translate and count, the expensive call would, instead of calling the real request.get, it would just get back a mock with this language in it. And because this had 4 words in it, the assertion passes because there were in fact 4 words in it. So patches kind of let you replace a specific function instead of having to override a whole like file of mocks or try to like pass in a mocked request class. You just kind of do it once. And because of the with syntax, that patch only applies to the code within that with. So if later you wanted to use the request library as usual, it would go back to normal. So that's kind of the sort of syntax and framing for how patching works. So yes, so instead, essentially it's as if request. So Monica, it's essentially as if request.get returned 4 words this time. So yes. So if this class called request.get function in multiple lines. So in this case, yes, it would, because you're sort of, you are kind of limited to replacing it within a whole like block. So if the same function like called request.get 3 times, then the code wouldn't be able to distinguish between the calls. So that is a limitation. Yeah. And I'm not sure exactly how I would handle that actually personally. Maybe if it was like really sensitive, I'd separate them out to kind of 2 different places in my code. But the idea is, yes, it sort of does apply to that whole like one block that you're looking at.
And I think to add on to that, Jessica, as a coming attraction, Anastassia, you're going to talk about how to do multiple sets of return values too, right?
Oh, actually, I forgot about that, but I can. No,
Okay.
You're right. I didn't think to include that in my lab, but that's actually a great point. So I can just throw it up on the screen.
Okay, cool. I thought I'd seen it in the slides, but maybe I forgot.
No, I wasn't gonna go over that, but that's a great idea actually to respond to Jessica's question. So what Stephanie is talking about is sort of the idea that while this will replace the whole request.get call, a mock can have different responses it returns every time. So I'm just gonna write it outside of a function because it's faster that way. So let's say we're gonna have a new mock. And like, instead of using the patch, I'm just gonna use a mock directly. So let's say it has a mock.get function. So for example, instead of having just a return value, you can have it have multiple return values. So instead of like having, I believe this is the syntax, we'll see. So now if we call mock.get, so the first, well, actually, do you remember the syntax? Because I seem to.
Oh, yeah.
Oh, yeah. So
Side effect. I think you have to do side effect.
Oh, okay. Yeah. Anyway, yeah. So, but the idea is that I think this should work now, is that now the first time you call mock.get, it returns 4 words this time. But let's say we create a new cell and this time we run it again. This time it's going to return hello. So that's sort of a solution. For example, if you had res1 and res2, you could instead write side effect and you could be like 4 words this time, and like or 3, for example, and then the 4 words this time would correspond to like this call, and the or 3 would correspond to this call. So does that bit make sense now for how you might be able to do that? That's great comment, Stephanie. I actually completely forgot about that. So
Yeah, thanks for showing that.
yeah, so that's another like element of what you might be able to do with patching and mocks. Mocks are sort of like patching sort of lets you inject mocks into specific places in a way. So they both have their use cases. Yeah, so I guess to finish off, I kind of had a little very silly example that combines like a bunch of different pieces we talked about. So I guess I'd say, like, do you guys just want to talk through it all together? Do you want to like maybe look at it for a few minutes and try it out yourself, and then we can come back together? Anyone have strong opinions? I'm going to talk through it first, but it's kind of a chance to try to write some more complicated tests right now. So anyone interested in any of that, or just have more general questions? Well, let's just go through it together then. So let's say we have this class that we're now going to like fully test, and it's a class for generating cat memes. So it's going to take in kind of like a logger and a database connection, because we want to maybe log to like an external system, and we have like a real database we want to connect to. And we're going to have some kind of machine learning algorithm to pick the best saying, which hasn't been implemented yet. And then essentially your main thing is going to be this generate meme class, which takes in a cat name. It pulls some sayings out of a database. Then it picks out the best saying, and it somehow transforms. It's like if it says I am, it says that the cat says that now or something. And maybe we have a second function which again sees if there are any duplicate sayings. Let's say we wrote this class that we might want to work with. And yes, it's a little absurd, but whatever. So now we want to write some tests. So I kind of already started this, but first thing first is that we want to essentially mock some parts of it, because we're going to just test the output, a couple of the different outputs. So the first thing we might want to do that I already wrote is like sort of come up with a fake database set of database results, because we don't actually have the real database available to us right now. So we're going to have 4 phrases, and the database, essentially, we're only going to mock the execute call, because we sort of know that execute is the one we're mainly going to call. And what we're going to have is have it always return this list of results, because that's sort of what works for our specific database. So then what we'll want to do is generate the full cat meme generator. And we're going to do like 2 things here. So first, because we don't actually care about any of the logging right now, we're just going to kind of replace it with a mock. And then because we're able to pass in the other fixture, we're going to pass in the custom database here. So this will let us create our cat meme generator. So the first thing we will want to test is sort of this. So the first thing we'll want to test is essentially testing that it works for a short phrase. So one of our rules was like, if our phrase has less than 5 words, then we want to have it output something that looks like this. So in order to do that, we will need to fake one of the calls. And in this case, we're going to fake the pick best saying call. I'm just going to actually go through the results because I get subconscious on the fly. But essentially what we're going to be doing is that the first part of the code we already looked at. So essentially what we're going to do here is that we are going to replace pick best saying with a short phrase of our choosing. So in this case, we're going to make the pick best saying function return the function this is funny. And then we're going to call the code now knowing that the actual phrase will be, this is funny. And we're going to make sure that the right if statement ran. So now we have Clark said, this is funny. And that kind of corresponds to the idea that once we pick the best saying, we kind of went into the second else if statement. So that sort of let us test that. And in a parallel way, my next one does about the same thing, but this time I'm testing the I am condition. So then another thing we might want to test is that the database was actually called. So we have our fake database, and as you know, the database had to be called. So we can just run this code, and this time we don't need to patch it because we're not really caring about the outputs. But because this DB connection, which we passed in here, exists, we can sort of make sure that the database was actually called. And finally, we can sort of test this check duplicates function because if we look all the way up here, we sort of specified the output of the execute command. And because we did sneak a couple of duplicates with the meow, meow, meow phrases in, we were also able to sort of test that the whole like set of the list equals the length of the list thing works as expected. So this sort of has like a bunch of things together. So as you see, we have fixtures, which we talked about for creating a database. And sometimes you might like create a little local database for testing. In this case, we're just like, let's just mock the database. We showed that, for example, that we can mock over things we don't care about at all, and then they'll just not break. So whenever the function calls logger.info, the mock just creates another mock and we can just ignore that. And again, we also have fixtures being called within other fixtures. And finally, we sort of have a mix where we're patching a specific function call without mocking the rest of the class. But we're using kind of the mock as a way to sort of manipulate the different return values. So that sort of ties together all the different elements that kind of we talked about today in like a fairly straightforward way. And if we now run this again, so going back to like the whole thing where we wrote this as a file, well, we see that that failed because I forgot to run this file that had the actual class first. But now if we go back and run this, we'll see that all of our tests passed. So that's sort of the short version of mocks and tests in Python. This is sort of like has gotten me pretty far, this amount of knowledge of my testing. I'm not as familiar with integration testing, but if someone else is, I'd love to hear from you. But this is sort of the short version of how you can start building more complicated tests. Yeah, so I think we have some time now for Q&A or general chatting. So if anyone has anything they'd like to bring up, go for it. So the collab, you should, I guess maybe if you joined later, I'll read if the link to the collab is on the event, and here I can share it again. Yeah, again, also always happy. I'm on the Women Who Code Slack, always happy to chat about other things. As I said, my specialty is more in machine learning and data science. So you should be able to find me by my name and feel free to ask.
And if you're not on the Women Who Code Slack, you should join. We're really friendly. There's lots of different channels about topics like data science, Python, jobs, general chat. Yeah, so Neha, do you have a link for that for people to sign up? It's a private group, so you do have to apply, but that's to keep trolls and other weirdos out.
Yeah, just a second. I'll share that in the Slack once.
Yeah, well, this was really fun for me too. It's always good to, I love talking about things because it makes me realize I don't understand them super well, but hey, we're all here to learn.
So Neha just posted the bit.ly to join the Women Who Code Slack, which is, like I said, our kind of like internal chat group. If you're interested, you can sign up, and then if you want to say like who told you about it or whatever, you can put any of us from tonight. We just want to verify that you're a real person and you want to join to participate. It's a pretty nice space and it's pretty good vibes, and I think it's a really good place to talk about stuff, especially if you're learning, because most people there are very helpful and friendly. And like I said, it's no trolls. So I think that's a good plus for me. There is a Women Who Code, Sharda, there's a general Women Who Code that I think they also have like a global Slack, and this is for the DC Slack. So it's a smaller group, kind of more for the DC area.
I'm in close to DC area. I'm in Arlington, Virginia.
Oh, perfect. Yeah, then definitely fill that one out and come join us. And we're hoping at some point, obviously when coronavirus chills out, to have in-person meetings again. So like,
this is
Go
the
ahead.
link that I have to complete the form. Is this
Yep.
the link? Okay, I will.
yeah, that bit.ly that Neha posted goes to a form.
Okay.
And it's not asking for anything like super personal or whatever. We're just making sure people are real.
Can you give me your email also, so that if I have a question that I can communicate with you? Name and email, so that I just want to make sure, because I used to attend the Women Who Codes event mostly, but nowadays I'm not. So, but I'm willing to start. Thank you.
Yeah, and I think, I don't know, Neha, do you know, have you heard anything about when we might eventually have in-person meetings again?
No, not really. The like global will not decide just for like US. They want to like, have
Worldwide, okay,
concerted, statement. So
cool.
But this virtual is best, because in a DC it's hard to find out the location, and the parking is just a lot of issues.
Yeah, parking in I haven't parked in DC for over a year. I've kind of blocked out how bad that was.
Yeah, I know. So it's but this is really cool to be in a Zoom meeting.
Yeah, it's definitely fun. I posted my email. I'm one of the TAs, so if you have questions, feel free
Thank
to
you.
reach out.
I will do that, Stephanie. It's a great session. Thank you so much.
Yeah.
So
Yeah,
we are done
Anastassia,
for the day, right?
Yeah,
Say that
we're
again?
done, unless anyone wants to like ask about anything else, but yeah, I think that was all the material.
Okay.
And then Anastassia, do you have any good general, I guess, references for people, like if they're looking to learn more about testing?
So I feel like I'm not sure specifically right now. I can look some stuff up. I actually think that the pytest documentation is pretty good, but I do not have like specific websites. I could Google around and see, but a lot of it's kind of just looking at how other people I've worked with done it is sort of how I've learned.
Gotcha.
Work.
Anastassia, do you also have any like, tips for like good testing practices? Like all that you shared was like obviously great, and but like, any with respect to like, I'd say like interview questions.
With respect to, I guess, I mean, I feel like an interview question might be maybe just about like the different types of tests that exist. Like, I think that might be what I can see being asked in a more general, like software engineer interview. And for that, the main types would be like, as I mentioned in the beginning, unit tests and integration tests, whereas unit tests are a lot what we looked at today, where you're trying to kind of test one specific unit of code, like usually within like one code base. And integration tests sort of test how like all your live systems work together and ensure that all your systems are talking to each other. So I'd say you might be asked about that as an interview question for a more general purpose role. Like obviously if you're applying for like a testing software engineer role, like you probably need like way more in-depth knowledge than what I have, but I think that might be a good general purpose software engineer question. I mean, all the tidbits I talked about today, if people ask you about like what goes into your tests, like obviously a lot of modularity is good. So you want your tests to like look at one specific piece of your code. You want to separate other things that go wrong from your actual tests. So that's like the fixtures. So I think maybe bringing in a few principles like that, if people ask you just about what are good testing practices, are like things that I think I'd want to hear from the person being the interviewee, but I can't speak for like testing positions specifically.
Yeah, of course. No, just a general one. Thank you so much. Yeah, that was a.
And I think for the integration testing, do you think it includes more the API testing?
Probably yes. I think once you have APIs, yes, that would count more as integration testing.
Yeah, because I saw that, because I did in a recent project. Right now I'm looking for a job, but in the recent project I did a lot API testing and it's interface testing. So I believe it's integration testing.
Yeah, so I think they're slightly different concepts, like, because not everything is done with APIs just because sometimes you're like, you don't have a server, you have just a bunch of libraries. So
Oh,
I think,
okay.
like not everything is necessarily an API. So I actually linked to this in the meetup, but here's a tutorial on GitHub on kind of Python testing, which I sort of reviewed myself the first few chapters. So the one I just linked there, but yeah, so for API testing, I mean, I don't know as much about API testing, but that's that. I think you'd probably need resources beyond pytest to do that.
Okay, thank you.
Neha, going back to your question about interviews and test questions, one of the things that I tend to ask is, what would your test cases be? So like, what kind of stuff are you going to test? And, there's like your happy path of everything's working great, but there's also the weird edge cases that you want to look out for, exception cases, things like that. And being able to say, like, to make those distinctions, to say like, yeah, I'm going to test, these expected normal operations, but I'm also going to expect when things go hairy or there's an edge case that I know could happen. So I'm going to make sure my code's handling it.
Yeah, if it's one of those more like you just coded something like live sort of interviews, then I would sort of like mentally like maybe scan through the code, and each time you have like a condition, maybe like where you like look up something in a dictionary or you assume something has a length, just like list them out, because I think maybe in an interview like that it's good to be thorough. So like just sort of maybe think of a mental checklist of like, could I be out of bounds with this list? Like, am I expecting a certain length? I would like I don't have a specific checklist, but I would just sort of like scan through it if you're like there in the interview and sort of point out all the cases. And then maybe you're like, I sometimes like, I was like, do we want to handle this case? And then, yeah.
Right. Yeah, I think that's a good way to think about it. And also to be able to say, I'm assuming that we don't care about this, or we'll let this blow up, or we're going to ignore this, and stating out those preconditions up front. One of the things you might look into is that I've seen a lot of our QA people use the given when then framework, where given your preconditions, when something happens, this is what we expect. And they use that a lot to test the user stories against front-facing code. So I think that's another nice way to break it out and to think about it.
Mhm. And would you like just if nobody has any other question, like following up on that, would you say like in general test suites should be like, I don't know, this is like an extrapolation, but like part of like, you know, your linting, or like, you know, is having like a local test setup better in a, you know, like organizational practice? Yeah, I recently had those questions. I was just like curious.
Yeah, those are good questions. I think it kind of ends up being a little bit of both. So I personally, when I'm developing, I'll run the test suite locally before I commit my code up onto a branch. And I want to make sure the tests are passing. We're using Bamboo to kind of build the branches as they go in for like our CI/CD pipeline, and the tests will run there as well. So if the tests fail there, your branch is marked as a failure at that point, and it can't go into like the main branch for deployment anyway. But I would say, yeah, like you want to be running, if you're using like a test-driven development kind of methodology, then you would want to run stuff locally, and not even necessarily the whole test suite, but you know, maybe even the part that you're just working on, and to be able to, you know, test change, and make sure that things are doing what you expect, especially as things get more complicated and like bigger and I guess more complex. That helps to keep that context switching pretty fast and keeps you from having to hold it all in your head, I think.
Mhm. Thanks, Stephanie.
Yeah. There was a second part to your question. I think I forgot it.
Oh, yeah, it was just like a, you know, like a organizational best practices for like,
Okay.
should it be like, you know, like part of linting or local, which you just answered.
Gotcha.
So, yeah.
I mean, yes, I think a lot of places now like will have it run before you're able to merge your branch. So even if you're like not
Yeah.
doing it locally too much, there's usually like basically you can attach different systems onto GitHub, which will essentially run a bunch of steps before you can merge. So for a long time, the company I worked at used the one called Circle CI. Right now, Github Actions is like a newer thing where GitHub basically build their own tool for doing that. And essentially, whenever like say you push your code, it creates like a little virtual environment from where it runs all your tests. So it's kind of automated in that way. But yes, ideally before you start pushing, you're always doing it locally. But I think for larger code bases, that's a good practice to implement like that.
Thanks, Anastasia. Yeah, we have been like using that, you know, it runs automatically and like the CI/CD thing. But yeah, like did not know a few like technical phrases for like this process itself. So yeah, this was great.
Yeah.
Cool. I guess one last call for questions. If people have general testing questions or questions about the collab
Or anything else.
or anything else.
This is Maria. I just have a quick question. I am new to Python and then testing also. I just wanted to see if you guys recommend anything. What's the best practice to always integrate testing as you are learning how to code in Python?
So if you're just learning to code in Python, like you could always, if you want to practice testing, like have like maybe have all your code and then in that same like folder or like repository, make a file like called like tests. So if you'll go back to the collab, we were actually writing out some files, and then in your testing file, you can import the other modules and run pytest in the command line. But if you're just learning, I think it's not necessarily the first thing to where you're master, but you can always sort of copy the way I did it, where I made up my classes and had a second file of tests. And then you can just run that for the command line and see that your code works the way you think it works. But when I'm just first starting stuff out, especially because I work with a lot of data exploration, I will just essentially do like print statement validation, where I'll just put print statements in the middle of my code and make sure it does what I think it does. So I think if you're doing something brand new, it's not always worth it to build out the tests right away, especially if you're just figuring out how things work. But that's just one perspective on it.
Yeah, I think printing stuff out like that while you're playing around and learning is totally valid. And you'll run into people who are like, ew, print statements, that's gross. But I still do that. And I've been programming Python for a few years now. Because you're basically kind of doing it, and you're doing the tests manually at that point, right? So one thing you might try to do while you're learning is maybe even on a piece of paper or in another file, write out what you think the test cases should be. And then, you know, use the print statements to kind of verify that. So like if you're writing a function that, I don't know, like does a math problem or something, then you know what the inputs are and you know what the outputs should be. So like just kind of write out those cases and then verify it manually with the print statements, like Anastassia was saying. And then once you get comfortable with the Python itself, that's when I would start adding in like the writing of the Python tests. Because sometimes when you're starting, it's just too many balls in the air. But the process of thinking about the tests, I think, is really good to start early and to just have that idea in your head of like, you know, this is just a function and it's literally only going to do what I tell it to do. It's not smart. So
right. Yeah, I just had someone said that just think about that, just start implementing the testing part of your code. So that's what I was.
yeah, I mean, if you want the challenge of doing both at the same time, go for it. But
I guess I just heard one perspective from someone that's kind of like the best practice, but that was just from one person's side. That's why I wanted to check.
Well, you'll run into other people too who think that testing is a lot of overhead and it's a waste of time. So this is like one of those areas where there's a lot of opinions. So kind of feel it out and end up where you feel like you're comfortable the most, and you know, read a lot of stuff and kind of play around with it. One thing that I think I've noticed about developers in particular is they tend to like to state opinions as facts. And so, you know, like if you ran into the guy I work with who thinks testing is the stupidest thing ever, like he would be like, oh, don't write tests, you're killing me. I think it's more like a personal thing, like, you know, feel it out. If you like them, use them. I like them because I mess up a lot. So I think they're a good thing to have.
All right, thank you.
Mm-hmm.
Yeah, well, I loved all of your questions as well. And yeah, I mean, maybe like couple more minutes and then feel free to just post on that Python channel on the Women Who Code Slack. We can also have like a little follow-up there. So yeah. Well, I think have a great rest of your night and we can wrap it up here.
Thanks, Anastassia. Thanks, Stephanie.
Thank you. Thanks everyone for coming.